Magandang araw mga kasipnayan! Welcome to Sir Ocnic's YouTube channel. In this video, we are going to recall arithmetic means and we will define and solve the arithmetic series of a given sequence. To start off, let us identify arithmetic means of a given sequence. Insert 4 arithmetic means between -4 and 11. That means that a sub 1 is equal to -4 and a sub 6 is equal to 11. Solving for the value of d using the explicit formula, we will then have a sub 6 is equal to a sub 1 plus quantity 6 minus 1 times d. Substituting the given facts to the explicit formula, we will then have 11 is equal to -4 plus 5 times d. That is equal to 11 plus 4, which is equal to 5d. Simplifying the left side of the equation, we will then have 5d is equal to 15. Dividing both sides by 5 to eliminate the numerical coefficient of d, that is equal to d is equal to 3. Since the common difference is equal to 3, that is equal to -4 plus 3 equals -1 plus 3 equals 2 plus 3 equals 5 plus 3 equals 8. That means that a sub 2 is equal to 11, a sub 3 is equal to 17, a sub 4 is equal to 23, and a sub 5 is equal to 29. We therefore conclude that the arithmetic means between -4 and 11 are -1, 2, 5, and 8. Insert 3 arithmetic means between 7 and -9. That means that a sub 1 is equal to 7 and a sub 5 is equal to -9. Solving for the value of d using the explicit formula, we will then have a sub 5 is equal to a sub 1 plus quantity 5 minus 1 times d. Substituting the given values to the explicit formula, we will have -9 is equal to 7 plus 4 times d. -9 minus 7 is equal to 4d. Simplifying the left side of the equation, that is equal to 4d is equal to -60. Dividing both sides by 4, that is d is equal to -4. Since our common difference is equal to -4, we will then have 7 minus 4 equals 3, minus 4 equals -1, minus 4 is equal to -5. That means that the three arithmetic means between 7 and -9 are 3, -1, and -5. What is an arithmetic series? An arithmetic series is the sum of the terms of an arithmetic sequence, which is given by the formula S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. And S sub n is equal to n over 2 times the quantity 2 times a sub 1 plus quantity n minus 1 times d. The second formula is used if the sum is given but the last term n is not given. In the formula, n refers to the number of terms, a sub 1 is the first term, and a sub n is the last term. Find the sum of the first 11 terms of the sequence -12, -5, and 2. Since the arithmetic series formula requires the first term and the last term, let us solve first for the 11th term of the sequence. That is equal to n equals 11, a sub 1 is equal to -12, and D is equal to negative 5 minus negative 12, which is equal to 7. Solving for the 11th term, we will then have a sub 11 is equal to negative 12 plus quantity 11 minus 1 times 7. That is equal to negative 12 plus 10 times 7, which is equal to negative 12 plus 70. Therefore, a sub 11 is equal to 58. Since we now have a sub 1 and a sub 11, we may now compute for the arithmetic series. Substituting the given values, we will then have S sub 11 is equal to 11 over 2 times the quantity negative 12 plus 58. That is equal to S sub 11 equals 11 over 2 times 46. S sub 11 is equal to 11 times 23, which is equal to 253. That means that the sum of the first 11 terms of the sequence is equal to 253. Find the sum of the first 20 terms of the sequence 3, 8, and 13. Let us try first to identify the 20th term of the sequence, wherein n is equal to 20, a sub 1 is equal to 3, and d is equal to 8 minus 3, which is equal to 5. Substituting the given values to the explicit formula, we will have a sub 20 is equal to 3 plus quantity 20 minus 1 times 5. A sub 20 is equal to 3 plus 19 times 5, which is equal to 3 plus 95. Therefore, a sub 20 is equal to 98. Since we now have a sub 1 and a sub 20, let us substitute the given values to the arithmetic series formula. That is, S sub 20 is equal to 20 over 2 times the quantity 3 plus 98. Simplifying the parentheses, we will have S sub 20 is equal to 10 times 101. We therefore conclude that S sub 20 is equal to 1010, or the sum of the first 20 terms of the sequence is 1010. Find the first term of the sequence if S sub 18 is equal to 1800 and A sub 18 is equal to 185. Let us identify the given facts on our problem. S sub 18 is equal to 1800, N is equal to 18, and A sub 18 is equal to 185. Solving for the first term, let us now try to substitute the given facts to the arithmetic series formula. That is, S sub 18 is equal to 18 over 2 times the quantity A sub 1 plus A sub 18. That is equal to 1800 equals 9 times A sub 1 plus 185. Dividing both sides by 9, we will then have 200 is equal to A sub 1 plus 185. Applying the addition property of equality, that is equal to A sub 1 equals 200 minus 185. Therefore, our A sub 1 is equal to 15. How many terms should be added in the sequence 3, 6, 9 to sum up to 165? Let us identify first the given facts. A sub 1 is equal to 3, S sub n is equal to 165, D is equal to 6 minus 3, which is equal to 3. In this case, we will use the formula S sub n is equal to n over 2 times the quantity 2 times a sub 1 plus quantity n minus 1 times d. Substituting the given values to the formula, we will have 165 is equal to n over 2 times the quantity 2 times 3 plus quantity n minus 1 times 3. That is equal to 165 is equal to n over 2 times the quantity 6 plus 3n minus 3. Simplifying the terms in the parentheses, we will have 165 is equal to n over 2 times 3 plus 3n. Multiplying both sides by 2, we will then have 330 is equal to 3n plus 3n squared. 3n squared plus 3n minus 330. Dividing all terms by 3, which is their common factor, that will be equal to n squared plus n minus 110 is equal to 0. Since we now have a quadratic equation, we may factor this one out. Let us try to identify the factors of n squared plus n minus 110. And those are quantity n minus 10 times quantity n plus 11. Equate both factors in terms of 0. That is equal to n minus 10 equals 0 and n plus 11 is equal to 0. Solving for the values of n, we will now have n is equal to 10 and n is equal to negative 11. Since we are asked to identify the number of terms, we are going to accept n is equal to 10. And we are going to reject n is equal to negative 11. Take note that we are going to accept positive integers since we are asked on the number of terms to be added. We therefore conclude that there are 10 terms in the sequence 369 to sum up to 165. How many terms should be added in the sequence 5, 9, 13 to sum up to 119? Identifying the given facts, we will then have a sub 1 equals 5, s sub n is equal to 119, and d is equal to 9 minus 5, which is equal to 4. Using the same formula, substitute the given facts to the formula. We will then have 119 is equal to n over 2 times the quantity 2 times 5 plus quantity n minus 1 times 4. And that is equal to 119 equals n over 2 times 10 plus 4n minus 4. Simplifying the terms inside the parentheses, we will have 119 is equal to n over 2 times 6 plus 4n. Multiplying both sides by 2, we will then have 238 is equal to 6n plus 4n squared. That is equal to 4n squared plus 6n minus 238, which is equal to 0. Dividing all the terms by 2, we will then have 2n squared plus 3n minus 119 equals 0. Factor out the given quadratic equation. The factors are n minus 7 times the quantity 2n plus 17. Equate both factors in terms of 0. And that is equal to n minus 7 equals 0 and 2n plus 17 is equal to 0. Therefore, we will then have n is equal to 7 and n is equal to negative 17 over 2. Since we are asked on the terms, total number of terms to be added, we will accept n is equal to 7, and we are going to reject n is equal to negative 17 over 2. We therefore conclude that we have 7 terms to be added to sum up to 119. Let us now try to summarize what is discussed in this video. An arithmetic series is the sum of the terms of an arithmetic sequence. S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n, and S sub n is equal to n over 2 times the quantity 2 times a sub 1 plus quantity n minus 1 times d, wherein this formula is used if the sum is given but the last term and n is not given, wherein n is equal to the number of terms, a sub 1 is equal to the first term, and a sub n is the last term. Let us now check your knowledge. Solve for what is asked. Again, do not forget to pause the video while you are answering. I think you are now ready to check your work. Find the sum of the first 16 terms of the sequence 10, 6, and 4. Using the formula S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n, try to solve first for the 16th term of the sequence, wherein n is equal to 16, a sub 1 is equal to 10, and d is equal to 6 minus 10, which is equal to negative 4. That is equal to a sub 16 equals 10 plus quantity 16 minus 1 times negative 4. A sub 16 is equal to 10 plus 15 times negative 4, which is equal to 10 minus 60, or simply negative 15. Since we now have the values of a sub 1 and a sub 16, let us substitute the values to the given formula. That is equal to S sub 16 equals 16 over 2 times the quantity 10 minus 50. Simplifying the equation, we will then have S sub 16 is equal to 8 times negative 40, which is equal to negative 320. How many terms should be added in the sequence if S sub n is equal to negative 15, a sub 1 is equal to 12, and d is equal to negative 3? The given facts are a sub 1 equals 12, S sub n is equal to negative 15, and d is equal to negative 3. Using the formula S sub n equals n over 2 times quantity 2 times a sub 1 plus quantity n minus 1 times d, we will then have negative 15 equals n over 2 times the quantity 2 times 12 plus n minus 1 times negative 3. That is equal to negative 15 equals n over 2 times the quantity 24 minus 3n plus 3. Simplifying the terms inside the parentheses, we will then have negative 15 is equal to n over 2 times 27 minus 3n. Multiplying both sides by positive 2, we will then have negative 30 is equal to 27n minus 3n squared. That is equal to 3n squared minus 27n minus 30 is equal to 0. Since all terms are divisible by 3, let us divide the whole equation by 3. That is equal to n squared minus 9n minus 10 is equal to 0. Factor out the quadratic equation that is equal to n minus 10 times the quantity n plus 1. Equating both factors in terms of 0, we will then have n minus 10 is equal to 0 and n plus 1 equals 0. Solving for the values of n, we have n is equal to 10 and n is equal to negative 1. Again, since we are asked on the number of terms to be added, we are going to accept n is equal to 10 and reject n is equal to negative 1 because this is a negative integer. We therefore conclude that there are 10 terms to be added in the sequence. Thank you for watching Sir Ocnic's YouTube channel. If you think that this video is a big help, hit like, feel free to share, and do not forget to subscribe. Again, always have fun in learning math. Enjoy learning. Thank you and God bless.